Okay, this is number 3 on the Target 4 worksheet. It's the last proof on that worksheet. We start with 3 different givens. What's interesting, maybe, for number 3 is that the first given, segment AB is congruent to segment DE, is not very useful because knowing that those two segments are congruent doesn't tell you anything. You're trying to show that BC and EF are congruent. So just knowing that those two segments are congruent isn't very useful. You could list it down first, but unless I have something I can do right away with it, I don't want to. This reminds me of when you were told something is a circle or a triangle as one of your statements, and then you were told it's large. Well, because it's large, then I could find out it was blue, and if it was blue, it was not a circle, and then because it's not a circle, it's a triangle. Like, there was something to do with one of them, but sometimes there's nothing to do with one of the givens right away. So that's what I think of with that first given statement. I just don't think there's much to do with it yet. So what I'm going to use instead is just skip to the second given statement. So my first statement is really that B, point B, bisects segment AC. And that is a given. So what does it mean if a segment bisects AC? Now, we know from solving problems in class that you can set the parts equal and they're the same size and all that stuff. So we want to go to our proofs. What does it mean to have a segment bisector? So right now, I have a segment bisector. They told me it bisects the segment. That means it's a segment bisector. So the only thing that tells me in a proof is that it intersects at the midpoint. So if B bisects AC, that means that there's a midpoint. Well, that tells me B is the midpoint. Of segment AC. So that's number 2, and that's the definition of segment bisector. Once I know it's a midpoint, what can I say? Because B is a midpoint of AC, okay, midpoint, midpoint. Because B is a midpoint of AC, I can get congruent segments. So if B is the midpoint of AC, then what are my congruent segments? Looks like AB and BC. So segment AB is congruent to segment BC. That's my definition of what a midpoint is. Now, one of the things I told you before was when you can use transitive, you should try to use transitive. So I'm going to scoot these things up. So I'll probably have to come down a little bit. So when you can see transitive, you should try to use it. So I recognize from my given that I have a segment AB, and in statement number 3, I have a segment AB. So I'm going to go ahead and use my other given now and set up a transitive. So my fourth statement, I'm going to put right below it, and I'm going to say segment AB is congruent to DE. That's a given statement. Notice I don't have an arrow going to this. It's just a given statement. It stands by itself. And then because of both of number 3 and number 4, okay, because of both of those, since they both have segment AB congruent to something else, the segments that AB is congruent to are congruent to each other. So BC is congruent to DE. That's statement number 5. That's the transitive property. Looks like I wrote a couple segment bars there. And I can also mark that on my diagram. So now I have AB, BC, AB, and DE. So I have 3 of the 4, and I just need EF. Oh, we got one more given. We've used the second given first, we used the first given second, and we're going to use the third given third. So it tells me I have a midpoint. That's going to give me something congruent, and then I can use the transitive property again. So my number 5 is going to go, or let's see, my number 6 is going to go underneath my number 4, and it says E is the midpoint of segment DF. So E is the midpoint of DF. Again, that's a given segment, or sorry, that's a given statement. Because I have a midpoint, that means I have 2 congruent segments. My 2 congruent segments are going to be DE and EF. So we say that next. Okay, that was statement number 7. That is the definition of a midpoint. So I've used definition of bisector once, segment bisector. I had a segment bisector that told me that I had a midpoint. And a couple times I've used the fact that if I have a midpoint, then I have congruent segments. Make that a little bit smaller so I have some space. So my very last step then, this is a longer proof, obviously. It's got 8 steps to it. We're going to use transitive again. I can use and check for transitive. Let's see, I have a DE and a DE. So whatever's left, BC and EF. Segment BC is congruent to segment EF because of the transitive property. We can see all the congruent marks already in the diagram. And that's what I was trying to prove. BC is congruent to EF.